So one of the whole points of our work is to convert this knowledge into therapeutic results. Now, we've gotten, thanks to all of you, a big stack of questions here, and I want to try to get through some of them. One of them comes up, and Judy, this relates to what you've been describing, but it's more specific, and it relates to what Bob's been describing because it's completely dependent upon an understanding of the basic science, and that is this. There was a lot of hype over the last 36 months or so about a specific class of drugs, and you alluded to them in your introduction, the PARP, PARP inhibitors. And it's probably worth, A, describing why they were so promising, and maybe just helping everybody understand where we are with those drugs now.
I wonder who actually even remembers these anymore. They seem like a flash in the pan, but they're not gone. So PARP inhibitors were drugs that, if you're in the BRCA1 and 2 segment of this breast cancer community, had a lot of hype. They were drugs that came along targeting an enzyme called PARP, which is part of the DNA repair machinery. And it was known already from the basic work that they would be particularly effective in tumors that were missing part of their DNA repair machinery already. That if you had a cell that was already, well, the analogy has been like the legs of a table. If it was missing one leg and you knocked out another, the table couldn't stand and the cell could not survive. And it was particularly important because this was really meant to target tumor cells that were already defective in missing both parts of their BRCA1 machinery, and now you knocked out another cell. Whereas normal cells, as we've said, had one normal copy, they'd be fine. So just what you wanted, a treatment that would be selective, that would kill tumor cells but not normal cells, and would do it particularly in an effective way without a lot of side effects. And almost all of these drugs, not all of them, were pills. So it seemed like a good idea at the time, and it probably still is. But it turned out, of course, to be a little more complicated. They had some side effects. And without a lot of editorial comment, I would just say that, you know, one thing to think about is that BRCA1 and 2 tumors are maybe fortunately a minority of breast cancer, maybe 5%. And if you're a pharmaceutical company, you want to invest in the treatment of the 95%, or at least more than the 5% apparently. So they wanted to see if they could identify other cells that would be sensitive. And that's a good thing because there surely are. But I think they jumped the gun a little bit and they skipped over the BRCA1 population, more or less, and they found that things were a little trickier out there. And they've now regrouped. And so they will go back to their basic business in breast and ovarian cancer in cells that are only in BRCA1 and 2 carriers, except based on some very exciting work here that Ursula's doing, that Gerber-Wolf is doing, that they have looked like maybe in combination with other drugs, maybe PI3 kinase inhibitors like Lutantly works on, that these drugs can be made more effective in a bigger group of patients. That would be a great thing because they exist and they're here. They just have to adjust the way they study these drugs to really prove where they're most effective. So I have been on the highs and lows of PARP inhibitors, thrilled, worried, concerned, and back to being cautiously optimistic.